And some of that comes back here in trigonometry. Okay, so let's dive in here. We are going to learn about two laws, guys: sine law, cosine law. There's no tangent law if you're waiting for that one. Okay, it's just sine law, cosine law. In IPR, or I think a lot of you, even in grade 9, right, you learned about what we call primary trig ratios. So that's your sine, cosine, tan, right? Or some of you, you will also remember the inverse operations. Those we use for angles, right? If you want to find an angle, you need to use the inverse. So you'll remember that. But I don't want to use it. It's still valid, but it only works, right? The primary trig ratios only work with right triangles, right? So they only work with right triangles. In grade 11 applied, we will learn how to solve oblique triangles, right? So I don't want you to think SOHCAHTOA is no longer, it does no longer work. It still works, but most of our scenarios do not, right? Are not going to be right triangles. And because you've been so ingrained with SOHCAHTOA, that's how I use it, right? An IPR, if you had me, that's how I would have done it, right? SOHCAHTOA like that. You're so ingrained with it that I don't even review it, because then a lot of you blank out on a test and you go back to that, right? So I don't even review it because you don't need it for this unit, right? So that's a right triangle. And so the ones you're going to see mostly are these kinds. They look like that. And those, right? So you might have an acute or obtuse triangle. And those, anything that isn't a right triangle is called an oblique triangles, right? And for those, we're going to use sine law as well as cosine law to work with those. You don't have any other option, right? And I'm going to introduce you to the sine law today, and tomorrow to cosine law. So this is what the sine law says in a nutshell. Okay. So just draw a triangle that does not necessarily look symmetric, like that. And then we're going to go ABC like this for the angles. And lowercase letters go across each of the angles, right? That's standard way of labeling a triangle. And I want you to pay attention to the fact that you're going to see a lot of pairing. You're going to see something that there's a relationship between the angle and the side across from it, right? Angle B and the side across from it. And angle C and the side across from it. So the pairing up is so crucial for this law, and even cosine law. You're going to see, hey, there's something about the side across from that angle, right? So this is what the sine law says. If you were to take sine of angle A, let's say, and divide it by the side across from it, making you work hard with all the highlighting, right? Sorry. Sine B over side B, that's what the sine law claims, that sine of A divided by the side across from it is going to be exactly the same as sine of B, angle B, and the side across from it. And you guessed it, you take that third angle remaining and divide it by the side across from it, and you would have exactly the same number appearing over and over. So those ratios are the same. I will give you an alternative way of stating this, and it's basically just flipping the sides come up. So I don't really use this one, but I think it's okay for you to at least know that it could be that some of my keys, sorry, some of my keys um, do have it flipped, and it doesn't matter. You'll get the same answer. Okay. So there we go. That's the sine law in a nutshell. That's your formula. That's all you need for a sine law, really. You need to just know this. Okay. So let's see if this actually works out. Sine law works for right. Oh, I'm just thinking of it now. Let's go back up here. You would have only been able to use SOHCAHTOA for right triangles, but sine law, cosine law works for all of them. So I feel like if you see this later and you review for your notes, you're like, oh, I can't do right triangles with sine law, cosine law. That is actually wrong. I will just make a note later. I think you're gonna be okay. But when it's acute or obtuse, for sure, it's only this one that works. Okay. I will just make a note later that sine law works for all, not just oblique. Okay. Oh, there it is. Sine law works for both right and oblique triangles. I keep on changing this booklet, so now I see that it's there, so that's good. Okay, I'm going to kind of pair this up, right? These are a pair. These would be a pair. And then that angle here pairs up with that side right there. Okay. So in no particular order, if you were to take sine of 101.39 degrees, right, and divide it by the side length across from it. This is drawn to scale, by the way. This triangle here is, I used the software to do that. And then you take any other angle, sine of 55.9, and divide it by the side across from it, 8.03. And we still haven't used this angle here, sine of 22.7 degrees over 3.74. I'm going to use this opportunity here. Do you see that the largest angle is across the longest side? I think we've talked about that. I'm kind of, I'm not sure, but that you should see that. And the shortest side is across the smallest angle. That's always true, right? That's always true. But let's figure out what these numbers actually give us. If we were to divide sine of 101, sine of 101.39, if you want to beat me to it, just close the bracket, okay? Divide it by 9.51. That gives us 0.1031, let's say. And then we go sine of 55.9, close bracket, divided by 8.03. That gives you 0.1031. And the last one, sine of 22.7 divided by 3.74. That is 0. Oh man, the rounding is going to be, you see how that's going to round to a 2? I was hoping that would have worked out, but it's approximately the same, right? If we had just rounded to 3 decimals, it would have worked out just fine. But, right, it holds true, right? So we just go check, right? Like it actually works out. What the sine law is claiming actually turns out to be true. If you don't close the brackets, you're going to get a different answer, I think. Is that what you're wondering about? Like if you don't close this bracket on the sine, It has to be typed in like that. So you have to close the brackets because this calculator will divide these first and then take the sign if you don't close the brackets. Does that make sense? Okay. That's good. That's good. Calculator check. I hope it doesn't bother you that I go equals that. You're going to be upset at me, right, if I do this? That's okay. I'll take it. That way we don't have to worry, because it's technically not equal if it's 3, 2, right? It's not equal. Because if we had used all decimals for the angles, this in fact would have been exactly the same, every single number. Oh, I'm jumping here. You may have had grade 12 students use your calculator. Let me address that real quick. It has to say degree at the top of your screen. If it doesn't, follow me. You just got to press mode, press the mode button, and then the third line down, or fourth. If radian is highlighted, just go over to degree and hit enter, and then you're good to go. I should have mentioned that right off the top. It has to be set to degrees, or else you're going to get a completely different answer. Was that a problem, maybe? Yeah, sorry about that. I usually have a grade 11 set and a grade 12 set of calculators, but last semester I had a greater number of students, so I had to kind of mix them up. So my bad. That'll solve your problem. All right, now that we know that it's true, let's put it to use. How's that useful? Well, obviously, triangles will not always have all the numbers provided, right? They will be partially filled in. You wonder why this book is so thick, right? Because instead of giving you a workbook and a notebook, I just merged it. And this is technically 2 units. A trig is split into 2 units, but I'm just going to do it all in one shot. Okay? So if it's a little scary, it's not meant to be scary. It's just I just like to have everything in one place. Okay? And you can do weights with it too, right? It's like a dumbbell. Okay. For sine law to work, you need at least one pair. That's important, right? If you see a known angle side pair, you know it's sine law. You know without a doubt that you're going to have to use sine law. Sine law works in the following cases. Just, I have this sectioned off, and it's not critical that you remember them necessarily, but the first one would be, let's just draw 3 triangles that look almost identical. So let's say you know this angle here and the side across from it, bingo, you know it's sine law. But they will only give you 3 things, right? So there's a pair, and then let's say they give you another angle here, check mark. So this is what we call angle, angle, side. Side angle, angle works too, but what it's saying is that there's 2 consecutive angles and 1 side, right? And then the other one is where you're given, let's say you know this angle and this side, so you know it's sine law. And I give you 1 more side. So it could be this side or this side, it's up to you, right? So if you go clockwise here, it would be side, side, angle. And yes, you can spell it the other way, but I'm not going to do it because it's not appropriate, right? But it's just focus on the pattern. And then the other one would be this. I give you an angle here, an angle there, and the side that's in between. This is what I call the hidden pair. This is the couple that hasn't made it official yet. They're not holding hands in the hallway yet. So this is the hidden pair. Okay. Why am I saying that? If you know two angles, you know the third one, right? Sum of 180. So technically, this one can be found, right? Sum of triangle is equal to 180 there's your pair. Sum of 180 to get that one. That's why it's hidden at first glance. You're like, there's no pair, but you can make it happen. So this is the, sorry, I'm struggling with my book. I can't bend the corner, so sorry guys, I'm going to try to make this straight there. So this is what we call the ASA. And this one is the easiest to, in terms of the letters, look at that. You have angle, side, angle, right? Like it could have been in any part of this triangle, but you have two angles on the side that connects them, right? That's in a sense where you have the hidden pair. And you're like, how am I going to remember these letters? It doesn't even make sense to me. What if I start here and it doesn't? Don't worry so much about these letters. Just try to find a pair. So I'm going to actually highlight that. I'm going to use green here, right? The most important part is that all of these cases essentially have a pair. It's just that one of them is hidden. Because if you have a pair, if you have to choose between sine law and cosine law, because remember SOHCAHTOA, you have to choose between one of the three. Same thing here. If you have a pair, it's sine law. Okay. Let's keep going. Largest angle will be across the longest side. And the smallest angle is across the shortest side. I always thought this was like this is a no-brainer. Everybody knew this. Sometimes students miss that. Okay. So if you're like, for example, let's say there's a question, it's like, hey, to fit this piece of furniture in that particular corner, I need an angle of at least 80 degrees. So some students just find all the angles in that triangle. It's like, no, just find the largest angle. If it's not 80, you can't, right? You can't fit that piece of furniture in there. So knowing this helps you out. Okay. Drawing and labeling a triangle. I know some of this is review, I know, but you can't be too sure, right? Triangle DEF has the following information. Okay. So when you see one of these, I don't really care if you draw it to scale. The only thing I care about is that you make sure you put the information where it should go. So I would always suggest, I call this the classic oblique triangle. And then you just use the letters. I tend to always start here, D, E, F. I go clockwise, but it really doesn't matter. Then you fill in what you know, right? This is lowercase e, lowercase d, lowercase f. And so angle D is 60 degrees. Side D is 5.2 centimeters. What did I do there? Oh, this is supposed to say angle F, guys. Two angle D's, right? Not cool. This is 50. Change that to F. Okay, F is 50. And then side F is 8.3. So there you have it. Partially filled in triangle. Can I just give you one more here? This is the only time that I care about how you draw it. Just copy this here. What kind of a triangle is this? It's oblique, but you should recognize, oh, this is bigger than 90, right? It's 102, right? So I would like you to at least make an effort to make that happen, right? Kind of just do that, and then the obtuse angle must be here. So this has to be C, which is 102. And the rest, I don't really care. You can go A, B, C. It doesn't matter to me where you put the rest. A would be 20. C would be 6 centimeters. And you're good to go. But make it look like that, okay? That would be the only time that I do care how you draw it. It will be important later on. And I just remind you on this little box here, uppercase letters for angles, lowercase letters for sides. And don't forget about the 3-letter notation for angles, just like in the previous unit. Okay. Okay. Now we're going to use the sine law. We're going to actually solve for sides. And remember, I always get you ready for word problems ultimately. But if you follow, you attempt the questions, you'll be fine. Okay, so let's go to page 4 here. Applying the sine law, and first we're going to do sides, right? And then we will do angles later. Some of the things you'll recognize, some of the things you will be brand new to you. Okay. Sometimes it will be a one-step scenario. Sometimes you'll need to do multiple steps to get your answer. So watch this. Determine the length of side B. So side B in this case is right here. So that's the one that they're asking us for. Now you need to figure out sine law or cosine law. You don't know cosine law yet, do you? But anyways, we'll still go through the motion. So you see that you have an angle and a side pair. That tells you I have to use sine law. Right? This would be the angle side scenario, by the way. Angle side, but it doesn't really matter. Okay. So watch my note here. So this would be your pair. So let's start that. Sine of 62 degrees over the side across from it will be equal to, if I want, right, I'm trying to solve for side B. That means I need angle B, right? I need to compare these two. So I can go sine of B over B. So that's a problem. There's two unknowns there. Need angle B. Angle B, in this case, is easily found. Right? I have 2 out of the 3 angles, and so that gives me 80 degrees. Right? Now I know that this angle is right here, and I found it, so I'm going to write it in. So let's do this again. Sine of 62 over 4.5 meters is equal to sine of 80 over side B. This is, now it's solvable because you have 3 out of the 4 unknowns there. And watch this. This is proportional reasoning, right? So it'll be b is equal to, you cross multiply like this, and then you divide by what's left over. So 4.5 times sine of 80 divided by sine of 62. So let's see here. Make sure you have no calculator issues. I would strongly suggest you close the brackets, right? I hit equals, then I go divided by sine of 62. And you get 5.02, right? 2 decimals for everything, even angles, okay? And we are in meters. So that solved the side that we're missing. So I'm just going to put an arrow to this 80 and just show that I plugged it in there, right? After a while, most students do this anyways before they set it up. Like, I just wanted to show you that as it stands, you had nothing. Okay. Could you have solved for side A, this side here? That would have actually been the best option to first solve for it, because you had your pair, and then it would have been sine of 38 over side A, and then you solve for A there. Okay. So that's up to you. Maybe I can fit that in. I will add that right here. Solve for side A. Okay. I'm going to box this in later so that it's an aside. So if this is what you're trying to do, I would always recommend you start with the pair that you were provided with. That is your best bet. Known pair, that is. And then I'm going to go sine of 38 to find side A. Because remember, guys, 38 degrees is across the side you're trying to find. So we can actually just call this side A for now here. And then this is just cross multiplying. So this would have been easier. And remember, 38 is the smallest angle in our scenario, should be the shortest side. Okay. So A is equal to, I didn't do this on my original, so I get 3.14. Okay. Let's box this in, because this is that was a complete aside. But now you've solved the triangle by the way, right? If you solve for all angles, all sides, you solve the triangle. I want you to try this right away by yourselves. Let me just give you a hint. Like, if you have two angles, find the third one right away. Just get it out of the way. There's chances that you're going to need it anyways. And it takes probably half a minute. Right? So I want you to try solving for side A only, and we'll meet. So the way it goes, most examples can be solved with sine law. 70% of the time is sine law. 30% of the time cosine law. That's just how it is. Like, a lot of real life examples, sine law is usually the go-to. So I start with sine law, then I turn over to cosine law. I'm just going to do this for notes purposes, because I do know that you got this. And if you didn't, that was just a small little hiccup. Okay? So you get 65 degrees for C, so that's important, right? And so that's 65 there. You have your pair, and we just pair them up. And since I want side A, this is important because sometimes word problems will be like, hey, find the distance between, Jennifer and the boat, whatever, right? So you got to make sure you find the right side. So you use the angle that's actually opposite to it, right? So in this case, it's sine of 30 over A, right? And so there you solve. Make sure you show me the steps, which I was seeing, okay? Just make sure you show me that intermediate step. I already make it easier than you probably would have seen it in IPR, right? You probably would have cross multiplied, right? And then divide, like it's the same idea, it's just a little quicker. And so that would be 8.00 if you round that meters. Okay. I don't know what B is, but I'm just gonna figure it out here with you. 14.5 sine of 85. That's the largest angle, supposed to be the longest side. Keep that in mind. I don't have this, so I'm just doing this right now. $15.94. All right. And I'm quite confident with that answer because it's the largest angle across from it, right? So we've solved the triangle, guys, just like that. Okay. So this is how you do sides. I'm going to show you how to solve for angles. Okay. So sides is there's not much to it. Set up, cross multiply, and divide, answer. When you do angles, there's going to be one extra step. I'll show you that. It's going to involve the inverse operation. So go with me to page 5 here. Page 5. So we're going to talk angles now. Sine law with angles. We're going to have to use the inverse function, right? And I'm going to actually sketch this one. Triangle XYZ has the following dimensions. Okay? So we're like, what is this? Sine law, cosine law? I don't know. I'm going to have to draw this for sure. I'll give you a secret. I'll tell you a secret where you can find out right away what kind it is. Sketch a triangle, then calculate the values of angle Z, angle Y. So let's go ahead and do that. I don't see an obtuse angle in the mix, so I'm just going to go with the safe, classic oblique triangle. And it's X, Y, Z. X is 34. Z is 3 centimeters. And side X is 6.2 centimeters. You see the pair? You could have actually seen that over here. Side X and angle X, right? That right there could have given it away, right? You have your pair. Sine law. Without sketching it, in this case, it's very obvious that it would have been sine law without sketching it. So let's go ahead and solve this. Same as before. You see a pair. Let me use a highlighter. You see this pair? Sine law. By the way, obtuse, acute, it doesn't matter. The textbook splits it in 2 chapters. We work with it the same way. Sine law has one problem, and that is chapter 4, the problem case. And until then, you won't have to worry about it. So let's go ahead and do that. Sine of 34 over 6.2, which is the only angle we can solve for as it stands. We can have a shot at Z because we have the side across from it, correct? Always pair them up. So we're going to go 3 centimeters here and we're going to go sine of z. So that's where it looks a little different, right? Just make sure you don't put z on its own, right? An angle should be glued to sine, okay? So you cross multiply and divide like that. You treat this as your variable. So it goes sine of z is 3 times sine of 34 divided by 6.2. And here's where we'll ask you to do this. You go, I usually don't like trains, like too many equal signs, right? But we can actually find out what this is. And it better start with a 0. If it's not 0 point something, you made a mistake. It's going to give you like a math error or something. It means that you didn't set it up properly. So 3 times sine of 34 divided by, right, so 3 times sine of 34, let's clear that. Clear my screen. Divided by 6.2, there it is, 0.270 dot dot dot. Just write down a couple of decimals and then you're good to go. So one line, right, 2 lines, here's your third line. Z, angle Z is sine inverse of 0.270 dot dot dot, okay? And that's where it is a little bit more work. So how do you type this in? You got to press second, right? On your calculator, the blue button there, second, sine. If you press second sine, it calls the inverse. Just go copy and paste what you got in your previous answer. And then hit enter again. And you get 15.698. So that round to 70 degrees. Done. So now you have 2 angles, right? I know 2 out of 3 angles. So I'm just going to go 180. So angle Y is what they want, right? Angle Y is 180 minus 34 minus 15.7. Angle Y is 130.30 degrees. Is it acute or obtuse? I think this gave it away, right? Triangle XYZ is an obtuse triangle because of that, right? So we're able to classify it as well. And now to review, I'm going to solve for side Y. So we solved all angles and I want to mix it up. So sine of 34 degrees over 6.2, that's my known pair from the very top. And then I'm going to, if I want side Y, then I need to use the angle across from it, which I just calculated. So there's an obtuse angle, no big deal. Cross multiply and divide. Let me see here, 8.46 centimeters. Does that make sense? It does make sense because it's the largest angle, should be the longest side. And always within the ballpark, right? It shouldn't be a couple hundred or something, right? If everything else is single digits, watch for those big numbers. 8.46 centimeters. D, you know what perimeter is, right? I hope. Perimeter is just the distance around, so if I ever ask you for that, So that's 9.2. $17.66. Oops, sorry. It's a bit low there. 1766 would be the perimeter. Distance around, right? That's what that is. All right. I insert it. A bunch of questions here. So I think I'm going to take a break here and get you to focus on the pages that follow. Okay, so you can practice what you just learned. And I'll tell you this. I took some from the textbook as well. Trying to see here. I don't want you to do all of it. So homework, page 6. $10 and 11. Page 6, 10 to 11. And notice that I give you a lot of space to do the work right on there. That's another reason why I made this booklet. So everything is in one place, right? When you do work in the textbook, I don't want you to have it on a loose leaf somewhere else. I want you to have everything in one place. But I will post everything from page 6 all the way to 11. I will post all of those. So if you want more, you go for it. Okay. So how about today? You make sure you get 6 done, and I think you're gonna have time to start the other ones. And that'll be it for today. So sine law, know how to solve a side, know how to solve an angle. I'll pause it here.